Welcome to session 304 in our discussion of your module assignment on research design. So, what should you have done by now? You should have already identified an employee or customer issue in the company you're working with and used that issue to phrase your research aim. You should have transformed that research aim into a problem statement and a few research questions. You should have determined what type of research your study is on the basis of your problem statement and research questions. And you should have made a logical decision as to what type of data and which data collection instrument is needed for your proposed research study. Today, we are going to talk about data collection instruments and sampling procedures for quantitative research. Specifically, we will talk about 3 quantitative data collection instruments: survey, observation, and experiment. And we will look at 3 probability sampling procedures: simple random, stratified random, and systematic random sampling methods. So, let's dive in. As we have discussed previously, a quantitative research approach is generally used for descriptive and causal studies. So, if your design study is a descriptive or a causal one, you should consider a quantitative research design. And for the purpose of this second-year module, we're going to talk about 3 quantitative data collection instruments. Let's start with the survey. In the previous session, we already talked about surveying in quite some details, so you're welcome to refer to my previous video. Today, let me outline for the purpose of your module assignment what are the most important points you want to take into consideration when designing the survey. Most importantly, surveys should contain mostly closed questions. We don't make a survey to ask the respondents to write out big, lengthy answers. For one, nobody's going to bother to do that, and also, that's not really the point of a survey. A survey is meant to collect quantitative data, not qualitative data. That is why surveys should contain mostly closed questions or items, so Likert scale items, multiple choices, ranking and ordering, things of that nature. Because ultimately, what we want from the survey is numerical, quantitative data. What is also important to bear in mind is that, generally speaking, we measure one particular concept using multiple survey items. For example, if we're measuring employees' power distance orientation, we do not ask the employees in one single question, what is your power distance orientation on a scale of 1 to 5? Instead, we need to use multiple items to tap into that construct. Or, another example, if we're trying to measure organizational commitment, we do not ask directly, how committed are you? Instead, we use multiple items to measure that. For almost all theoretical concepts that we can think of, there are usually already published and validated scales that we can use. And even if we cannot find a published validated scale for the specific concept we're planning to measure, we can ourselves try to come up with a meaningful scale consisting of multiple items or questions in order to thoroughly and meaningfully measure the concept in question. So that is the first data collection instrument, surveys. The second data collection instrument I want to talk about in this session is quantitative observation. The general principles are rather similar to surveying. Essentially, the observer has a list of items that they need to observe. Particularly for quantitative observation, this list would include closed questions or items, so once again, Likert scale items, multiple choices, ranking and ordering, or any question that calls for a direct numerical answer. Observation can be performed overtly or covertly, as a participant in the act or as a mere observer. Some of you may still remember that in the first-year module guest experience, you performed restaurant observation using a standard observation list provided to you by the school. Although in that particular study, you did not need to develop the observation list completely on your own, but you did make use of that instrument and performed observation in order to collect primary empirical data for the research report that you needed to write as part of the module assignment. So recall what you did in that module, because that's essentially how observation would work. Finally, the last quantitative data collection instrument, experiment. Let me cut away to another video in which I discussed experiment. Experimental studies are performed to examine cause and effect relationships. The idea behind this research design is to have a control condition versus an experimental condition or a few experimental conditions, so that the differences among the various conditions can be identified, which will enable the researchers to infer causality. For instance, if we want to know if a teacher's attitude has any effect on student performance, we will need to set up at least 2 conditions: a control condition in which a teacher teaches with a cool, calm, collected attitude, and an experimental condition in which the same teacher teaches with much enthusiasm and passion. Then, after a semester or so, we measure the potential differences in student performance between the 2 conditions in order to infer whether causality exists. As such, experimental studies are generally performed in the name of causal or predictive or explanatory research. So, surveys, observation, experiments. Please choose one for your design study and motivate in your paper why you have chosen it. So now we can move on to sampling. Today, let me present you with 3 probability sampling procedures. Generally speaking, or at least theoretically speaking, quantitative research would involve probability sampling because of a higher need for representativeness and generalizability. This is not to say, however, that a convenient sample, for instance, which is a non-probability sample, is always unacceptable for quantitative studies. But theoretically, at least, it is preferred that a probability sample is used for quantitative studies. So let's take a look at 3 probability sampling methods. We start by defining population, sample, and sampling. Simply put, a research population refers to all the people about whom we want to draw our conclusions. A sample is the group of people from within that population from whom we actually collect data. And sampling refers to the process through which we draw the sample out of the population. For instance, if my main research question is, what do hotel school students in Leeuwarden think about PBL? Then obviously the research population would be all the hotel school students in Leeuwarden, which would be about 2,000 people. But for my study, I will only collect data from 200 students. Then this 200 students will be my sample. And the process or procedure through which I choose the 200 students out of the 2,000 is known as sampling. There are 2 main categories of sampling procedures, probability sampling and non-probability sampling. And for each, we have 3 examples. With probability sampling, we as the researchers guarantee that every single subject from the population will stand the same chance or the same probability of being chosen as the sample. Hence the term probability sampling. In non-probability sampling procedures, obviously, we don't bother with guaranteeing equal probability. By this definition, probability sampling is always more complex and perhaps difficult to perform because we as the researchers have the duty of guaranteeing equal probability. The book talks about 4 probability sampling procedures, and we're going to run through the 3 most commonly used ones. The first one is simple random sampling procedure, meaning we establish a simple procedure to guarantee equal probability. For example, if I have a population of 100 and I need a sample of 20, I can put the 100 names into a jar, shake them up, and pick out 20 names with my eyes closed. Through this simple procedure, we can reasonably guarantee that personal bias does not exist at all, and that the 20 names that are picked out purely by chance. The second is systematic random. This procedure says that we take the population size and divide it by the desired sample size. As such, we calculate the skip interval. We pick a random starting point from within the population, skip the amount of subjects as identified through the skip interval, and pick the next subject. Mathematically, after we have run through the entire population, we would have selected the sample size that we desire. The third probability sampling procedure is stratified random. This is to ensure that whatever subgroups that exist in the population will be retained in the sample. For example, if we know the gender distribution in the population is 80-20 male-female, and we want this to be retained in the sample, we would need to create 2 strata, or 2 subgroups, one of males and one of females. So essentially, we break the population down into 2 subpopulations and sample them proportionately so that the gender distribution that exists in the population will also exist in the selected sample. Alright, so to sum up, what we have established today is that if you have a descriptive or a causal study, you should consider a quantitative research design. And in order to collect quantitative data, we can choose to use surveys, observation, or experiments. Finally, the preferred sampling method for a quantitative study, which would usually call for a relatively large sample size, would be simple random, stratified random, or systematic random. You may now further design your study for the purpose of your module assignment, write up your assignment draft, and I will see you next time.